Now that you can do Lewis dot structure, you should also pay attention to this statement and use it to answer questions. If you remember, we did C2H6, C2H4, C2H2 on slide before. So I wrote the same structure, and if you look at the bond length, which is in white, and this is picometer, 154 picometer, is distance between one carbon and another carbon. When you have double bond, the number goes slightly lower, 134 picometers. Triple bond gets 120 picometers. So you should remember, as you share more electrons between two atoms, the bond gets shorter in distance. The other thing is bond strength, which is enthalpy of bond, how much energy you need to break it. For a single carbon bond, it's 346. For a double carbon-carbon, it's 614. You need more energy to break it. And finally, triple bond, you still need even higher. So the shorter the bond, the stronger the bond. The more electrons you are sharing, the shorter, the stronger the bond is. Now let's just challenge you with one question. Which of the following two molecules, for example, have a stronger nitrogen to nitrogen bond? You have to do Lewis dot structure. So let's do for N2F2, let's do nasal as a practice one more time. How many electrons do I need? I have two nitrogens, each need 8, and I have two fluorines, each need 8. So you have 4 times 8, that's total of 32 electrons that you need. How many electrons do you have available? Nitrogen is group 15, so 5 and 5. Fluorine is group 17, so 7 and 7. You have 14 plus 10, that's 24. Subtract the 2, you are sharing 8 electrons. Subtract this 2, and now you have 16 electrons as lone. So let's just put it together. So there is a nitrogen, another nitrogen, put fluorine, put fluorine. Fluorines or halogens cannot have more than one. I need 8, I have 1, 2, 3, so I put a double bond here. Then I'm going to put my lone pair of electrons. This nitrogen is 1, 2, 3, I need one more, that's 4. 1, 2, 3, I put one more. Now fluorine needs 4 more to be octet. 1, 2, 4. So this is the Lewis structure for this. Now let's go after the next element. Let's go after, compound. N2F4. Need available shared lone. In this case, you have 6 elements, each need 8. 6 times 8 is 48. Then we add their valence electrons, and you have 38. Subtract the 2, you're sharing 10 electrons or 5 pairs. Subtract this 2, you have 28 electrons or 14 pairs. So I put nitrogen, another nitrogen, 4 fluorines, 1, 2, 3, 4. This will tell me I need one more, so this is the 5th one. Now let's go after lone pairs. Let's satisfy nitrogen, 1, 2, 3, so put one lone pair for this nitrogen, 1, 2, 3, one more here. Let's saturate fluorines, lone pair of electrons, and you can add them up, and you see you have used 14. Okay, so the answer for this should be which one is stronger is this. Now actually let me give you the values for this. Nitrogen double bond to nitrogen is actually 470 kilojoules per mole. And nitrogen single bond to nitrogen is 158 kilojoule per mole. If the question was which of these bonds between nitrogens is longer or shorter, this is the longer one, the single one. Let me also give you that value for you. That's 146 picometers compared to a double bond, which is lesser than 146, and that's 125 picometers. So remember the notion that the stronger, the shorter, the more electrons are being shared in that vicinity between the two nuclei.